y equals to 3x minus 5. Because the absolute value, puts a minus in when 3x minus 5 is negative, which happens over here. So anyway, integral from 0 to 2 of the absolute value of 3x minus 5, that's going to give us the area that we want, right? But to do that, we're going to integrate from 0 to 5/3, 5 minus 3x, and then we're going to add the integral from 5/3 to 2 of 3x minus 5. And that will give us the area. All right, let me do it. The antiderivative of 5 minus 3x is 5x minus 3/2 x squared. Evaluate from 0 to 5/3. And then plus parentheses 3/2 x squared minus 5x evaluated from 5/3 to 2. So I get 5 times 5, which is 25 over 3, minus 3/2 of 25 over 9, because that's 5/3 squared. And then I subtract 0. Thankfully, that's just 0 here. Plug in 0, you get 0, right? So, and then the next one over there, plus 3/2 of 4, 2 squared is 4, minus 5 times 2, plus 3/2, minus 3/2 of 25 over 9, minus 5 times 5 over 3. And then it's just a bunch of arithmetic. I mean, do you want me to finish it? I can, but... So... Now, this kind of thing on the test, I would actually like you to finish it. I want a number, Am I going to take a lot off for not finishing the arithmetic here? No, but I'll take off something because I don't want to check it. Honestly, I don't want to check it, And I'm going to take off other points from other people if they do it wrong, so I can't very well not take points off for you if you don't do it, So I do expect you got a calculator though, right? Let me do that. By the way, these calculators will do numerical integration if you study them long enough. Don't ask me how, it's complicated. All right, well, if I have not fat fingered something in my calculator here, we got 13 over 3 is the answer. All right. Okay, so with the last few remaining minutes of class here, I want to share with you the next major calculational technique. So at the moment we have all these educated guessing techniques, right? So the next thing we're going to move on to next week is what's called U substitution. All right, this is really the only major integration technique that I teach you this semester. We also look at integrals of trig functions, but that's just mostly trigonometry. But U substitution works like this. So here's an example. So let me show you something that would be hard maybe for hard for you guys to do with our current technology. Something like the integral of, I don't know, e to the tangent of x times secant squared of x dx. All right. So here's what we do. We let u equal something that will be helpful. In this case, I'm going to say u equals to tangent of x. So that makes du dx equal to what? Secant squared x, right? So if we solve that for du, we've got du equals to secant squared of x dx. See that? So with this substitution in mind, we can trade the integral we have for the integral of e to the u du. See, because this right here is just du. And this right here is my choice of u. What's the integral of e to the u du? This you guys already know, right? Yeah? No, integral of e to the u du. Mm-hmm. What's the e to the u, right? Plus a constant, right? Plus a constant. And then I undo the substitution. I put it back in. So that's e to the tangent of x plus a constant. So this, my friends, is the technique of quote-unquote u substitution. So we'll be taking an in-depth look at that method next week. All right. And I'll put some of these in your Mission 8. I wanted to show you at least an example of it so you had a chance of trying the problems I put in Mission 8 over the weekend if you want. If you don't, I won't put so many in Mission 8 that you can't do them before it's due next week, you know. But anyway, so have a good weekend. Watch out for that lady in the hallway. Don't want to. She might, become a target of her wrath.